Hello, welcome back. In this segment, we will solve an interesting problem. We need to write a clear argument to show that these three hypotheses are contradictory. The very first symbol I will use is A. A for Alan likes kangaroos. Betty likes frogs, let's call it B. Carl likes hamsters, let's call this C. So from the first hypothesis, right, we can say we have A as one premise and B or C as another premise, right? That's the first statement. Okay. What about the second statement? If Betty likes frogs, okay, so that means B is true. Implies Alan doesn't like kangaroos. Okay, that means B implies not A, right? That is the meaning of the second statement. So we're done with that part. If Carl likes hamsters, then Betty likes frogs. So Carl likes hamsters means C. If C is true, then Betty likes frogs, B. So what is that we need to prove? We need to prove that these arguments lead to a contradiction. Okay, at the end we should show this is not possible. You cannot satisfy all three statements. When I say a statement, every bullet is a statement. I am partitioning the bullet by reading the sentence and extracting premises and denoting them by A, B, C. And we have now symbols which we can reason about. So my goal is to prove correctness of this and claim that hypotheses are contradictory. Now I'll formalize it because in logic we formalize it using the ground rules like the natural deduction rules we learned. So we'll use the proof logic assistant to prove this. The proof assistant will help us to validate the proof. We will, as a human, we will drive the proof. Okay, this is more of interactive theorem proving. Yeah. So A is one hypothesis. B or C is one hypothesis or premise. B implies A. Next one is C implies B. Okay. The conclusion is just contradiction. That is the conclusion. I'll proceed using the case-based reasoning, right? Because we are given B or C is true. We don't know which one is true. It could be B true, C true. So we'll consider that idea. All right. So we'll go ahead and create a new subproof. We assume B to be true, assumption. But right away, we can see that we can eliminate the implies by combining line number 3 and 5, right? So we get a not A by combining lines 3 and 5. Because B implies not A in line number 3. If B happens in line number 5, we know it's not A. Okay. So it's just the elimination rule that we learned. What is the next thing we need to do? We can eliminate the not by combining line number 1 with line number 6. Okay. So not elimination of line number 1 and 6 will leave us into a contradiction. This is because of not elimination in line number 1 and 6. Let's check the proof to make sure we are on the track so far. Okay. Yeah. Nothing terrible. So far, we are okay. Let's do one more thing now. Let's create a subproof assuming C to be true. Line number 8 with line number 4. Eliminating implies we get a B, right? 4 with 8, sorry. 8 says C. C is an assumption, but C implies B in line number 4. That means you get B. I'm going to repeat whatever we did for B. If it is B, we can combine it with line number 3 to eliminate the implies to get not A. Again, implies elimination between line number 3 and 9. Okay, so we get not A. And then we can combine line number 10 with line number 1 to get a contradiction. This is not elimination, line numbers 1 and 10. Okay, but now pay close attention, right? This is the time to pay close attention. We know B or C is true. This is the assumption here. We have started with B being true. We end up with contradiction. We assumed C to be true. We end up with contradiction. That means we can apply or elimination rule we learned earlier because we know B or C is true. That should allow us to come to the conclusion that it's a contradiction. So I'm going to just say contradiction because of or elimination line numbers 2, 5 through 7, 8 through 11, right? Because if B is true, we end up with a contradiction. C is true, we end up with a contradiction. But we do know B or C is true. Therefore, in any case, we end up with a contradiction using the or elimination rule. Yeah, congratulations, the proof is correct. Okay, so we achieved our goal. In the end, we want a contradiction, we got it. Okay, thank you very much for your attention.